Hello. In this session, I'm going to continue to talk about graphs. So in the last session, I've talked about straight line graphs, about the equations, and about how to plot the graphs and how to get the gradients and the intercepts. Now, I shall continue with the straight line graph today. So let's start with supposing that we are given a set of two numbers. Suppose that we are given a table like this. Now, using this table, we know that we can plot a graph on a piece of paper. Now, suppose that we know when we plot the graph, we find that it is a straight line. So the question is, from this graph, how can we write down the equation for this straight line? So in other words, what is the equation for that relates x and y? Okay, what's the formula for finding y in terms of x? So if we know that it is a straight line, we can just plot the graph to check that it's a straight line and to find this equation. So let's see how to find the equation. So first, we draw on a piece of graph paper the horizontal x and vertical y axis. Right? Then we start plotting the points one by one. So that's goes from -1, 1 and 3. So let's say -1 is there, 1 is there, 2 and 3. Okay, y goes from -2 to 2, so -1, -2, 1, 2. There. So the first point would be -1, -2. So that would be -1, -2. There. 1, 0 would be 1, and that's 0. So that's 1, 0. And 3, 2, 3, 2 would be there. So we can draw a straight line through these points. That's a straight line. Now we can actually use this straight line to find the equation. So the way to do it is to remember the form for the equation of the straight line. So there is a formula for the equation of a straight line. It is y equals to mx plus c. So we looked at this in the last session, that an equation for a straight line must always look like that. Right? So m and c represents two numbers. Can be any number. So x and y are these values here that can have different numbers. Right, so to find the equation for this straight line means that I must find the numbers m and c for this straight line, or for this table of x and y numbers. So how can I find the m and the c from here? Now in the last session, we have seen that if you plot a graph of a straight line, then the m here is the gradient, and the c here is the y-intercept. So this idea, this knowledge tells us how we can use the graph to find m and c. Now the easier number to find is c. C is the y-intercept. So the y-intercept means the point where the line cuts the y-axis. Now in this case, if you have done it properly, carefully on a graph paper, you'll find that the y-intercept is -1, right? So the c there is -1. Okay, now to find the gradient, the way is to draw a triangle, a right-angled triangle with a vertical side and a horizontal side over the line. So it is convenient to use the points that we already have. So for example, let me draw the vertical side through that point. Okay, let me draw the horizontal side here. So I have a right-angled triangle and I can use this to find the gradient. And remember that gradient means the vertical divided by the horizontal side. So m is the gradient, and it's the vertical side goes from -2 to 2, right? So the vertical side is 4, and the horizontal side goes from there to there, from -1 to 3, so it's also 4, right? Therefore 4 over 4 is 1. That is the gradient, so therefore m is 1. So now we can write down the equation. It is y is equal to 1x plus -1. Alright, so if I write this out again, it's just 1x is just x. The -1 there gives a -1. Y equals to x minus 1. So we got the equation. So let's look at a slightly more complicated example. Let's look at an equation like this. Y is equal to x squared plus 1. Now I have mentioned in the last session that if I have a squared in the equation, then when I plot a graph of this equation, it will not be a straight line. In fact, the x squared will give a curve. So we'll look at this curved graph later on. But now I want to explain how we can use the straight line graph to plot this. Okay, now the way I can plot a straight line graph of this equation is that instead of plotting y and x, plotting y against x, I plot y against x squared. Now, what do I mean by that? So to see the idea, let me write down some values. So let's say x is minus 1, 0, 1. Okay? Minus 1, 0, 1. And let's say y, I can find from the equation, it would be 2, 1, and 2. Right, if I plot this, I would not get a straight line. Okay, so just to see that, let me do it quickly. If I plot x against y, minus 1, 0, 1, minus 1, 0, 1. Here is 2, 1, 2. So 1 and 2. So 2, 1, 2. So I would get a curve like that. Right? So you can see that this graph is not a straight line. So I was saying that I can plot this graph using a straight line. Now, what do I mean by that? What I mean is that instead of using x, I use x squared for the horizontal axis. So watch this. If I add an additional row x squared, okay, that means that if x is minus 1, x squared is 1. Okay, if x is 0, x squared is 0. And if x is 1, x is 1. Alright? So instead of plotting x and y, let me plot x squared and y. Plot y against x squared. So this is the graph that I want to plot. The horizontal axis will be x squared instead of x. Vertical axis will be y. And in order to plot this, instead of taking x and y, I will take x squared and y. So I will take 1, 2 as the pair of numbers. So let's say this is 0, this is 1, 1 and 2. Okay, so 1, 2 would be 1, 2. Would be there. The next would be 0, 1. 0, 1 would be there. And the third one is 1, 2. 1, 2. So it happens to be the same point. But what you see here is that I now have a straight line. I can now get a straight line because of this. Now you may think that there are only 2 points here, and of course you can draw a straight line through it. So to confirm that we can get a straight line, we can, for example, add another point, add another number here. Let's say when x is 2, then x squared is 4, okay, and y is, okay, 4 plus 1 is 5. Okay, we can add another point, and if you do that, you see that when x squared is 4, right? If you plot the 4 there, and if you go up to 5 here, you'll find that the next point will also lie on a straight line. Okay, it's a bit out of the board here, so I shall not draw that. Now, so why does a curve become a straight line? when I plot y against x squared. So the reason is this. Let me write this out again. Okay, now to understand this, compare this equation with the straight line equation. Now I'm going to write the straight line equation like this. I've used capital letters for the y and the x of this equation. The reason is that I want to make it look different from the x in the first equation. Okay? So this is a straight line equation. If I plot capital Y against capital X on the graph, I'll get a straight line. Now that first equation with the x squared, we already know that it's a curve, that is not a straight line. Compare the two equations. What if I let the capital X be equal to x squared? Okay, so that's algebra. We can let capital X be equal to x squared. Now I let the capital Y be the y. So we make this association. If I do that, then that should be a c then. Alright, y equals to mx plus c. Then c would correspond to the 1, and the m here would correspond to the 1 there. The x squared is the same as 1x squared. So if you let capital X be x squared, you can see immediately that if you plot y against x squared, it's the same as plotting capital Y against capital X. You must get a straight line. Okay, so what I've done here is the x squared there is actually capital X, the y there is the capital Y, and I know that if I plot capital Y against capital X, I have to get a straight line. So that is the reason. The reason why plotting y against x squared gives a straight line is because when I let x squared be capital X and y be capital Y, then this equation has the same form as the equation of a straight line. Now, why do we want to plot a straight line using this method? The reason is because in real life, in science or in economics or in different things that people do, where we have to plot graphs, where we have to use formulas, it often happens that you can plot a straight line between two different numbers using this method. And if you can plot a straight line, then that always makes the graph simpler, because a straight line is definitely simpler than a curve. And then from the straight line you can also get a simple formula to relate the two numbers. So let's say, for example, if I have a wire with a current going through it, an electrical current, then we can make a physics experiment to measure this current using an ammeter, and we can also measure, for example, the width of the wire. Now if we do that, we can get a table of values. let's say D and I. So I stands for current, and D could be the diameter. Alright, so suppose I have a wire with a current going through it, and I measure the D and the I. So suppose that the numbers I get are, for the D are 1, could be in millimeter, this could be in milliampere. So don't worry about the units now, it's not a physics class. We're just going to put in some numbers to see this example about how we can make an equation that relates, that gives a formula between diameter and currents. So let's say the D is 1, 2, 3. Okay, let's say I have 3 wires of diameters 1, 2 and 3 millimeters. Now then, when I connect this to a battery, so suppose that I measure a current flowing through it, and that this current is 1, 4 and 9. Right. Now let me change that a little bit. Suppose that the numbers are 0, 0.5, 2 and 4.5. Okay, now I want to find a formula for this. Now just by looking at it, it is actually not clear what to do. So suppose I tell you that actually these two numbers are related by a formula that looks like this. I is equal to A D squared plus B. So that looks a little complicated because we have 1, 2, 3, 4 symbols. Alright, we have I, A, D and B. Now A and B here are supposed to be numbers, okay, like M and C in Y equals to mx plus C. So A and B here are numbers that we must find in order to make this formula. And this is supposed to be a formula relating I and D. So we want to make this formula by finding the numbers A and B. Okay, so A and B are like two blanks that we have to fill in. So suppose I tell you that the formula looks like this, and that you must find A and B to complete this formula. So how can I make use of these numbers in the table to find the formula, to find A and B? So the way is to look at this formula and see that you can think of it as the equation of a straight line. Now, the equation for a straight line is y equals to mx plus c. Okay, that's the equation of a straight line. If I say that y is I and x is d squared, okay, so these are the numbers that can have different values, and then I say that the number m is the number A and the number C is the number B. So A and B is the M and C, and I and D squared is the Y and X. Then I know that if I plot I against D squared, I must get a straight line, because if I plot Y against X, I have a straight line, since this is a straight line equation. Now And I know how to find M and C if I have the graph for this straight line, because M here is the gradient and C there is the y-intercept. So therefore, if I plot I against d squared, I should get a straight line, and A would be the gradient because that corresponds to M, and B would be the y-intercept or the I-intercept because it corresponds to C. So let's try it. Let's plot I against d squared. Now before we do that, we need to make a row of numbers for d squared. Okay, because we don't have d squared here. So let me, I'm just going to write it out here again, d squared and I. Okay, I is 0.52 and 4.5. Okay, and d is 1, 2, 3, so d squared will be 1 squared, 2 squared is 4, and 3 squared is 9. So these are the numbers that I need. But now I'm going to plot I against d squared. Alright, let me make that bigger. Okay, I know that there are no negative numbers here, so let me just show the positive sides of the two axes. So that is 0. Okay, now d squared goes from 1 to 9. So let me do some quick markings. So that could be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 1, 2, 3, 4 to 9. So I'm doing this very quickly and very roughly. I goes from 0.5 to 4.5. So let's say, think of it as I put in markings from 1 to 5. So 1, 2, 3, 4, 5. So that's 1 to 5. So 4 is there, 2 is there, 3 is there. Okay, we are ready to go. The first point is 1, 0.5. So that's 1. 0.5 is somewhere there. That's 1 point, roughly. The next point, 4 and 2. 4 and 2. That's 2 and that's 4. So the point is there. Okay. Finally, y and 4.5. 9 and 9 is there. 4.5 is here, between 4 and 5. Okay, so here and here. Okay, so roughly that's the point. Now you can already see that they are roughly in a straight line. Let me try and draw that. Okay, it's not very straight because I've done it very roughly, but if you try and do this carefully on a piece of graph paper, you'll find that you get a very straight line. So, but you get the idea here. Okay, if you plot I against d squared, you would indeed get a straight line. So now that we have got the straight line, let's come back to the formula and try to find this formula. Now we want to find A and B. If we know these numbers A and B, we have the formula, and we know that A is the gradient and B is the intercept. So let's look at this graph. Okay, let's start with the intercept. always the easy one, where the line cuts the vertical axis. So in this case, instead of y-axis, you have the I-axis. So it cuts the vertical axis at 0. So C, or rather the intercept is 0. What is the gradient? So like before, it would be convenient to draw the right angled triangle from one of the points that we know. Okay, so this time I'm just going to draw it from this point there, comes down to 9, and the horizontal line, I'm just going to use the x-axis, right? Because it goes to the straight line at 0. So it's so that's convenient. Now I want to find the gradient, and the gradient is the vertical side divided by the horizontal side. Horizontal is 9. Okay, so that's simple. The vertical for that point we know is at 4.5. We know from that 9 and 4.5. So the vertical is 4.5. So therefore the gradient is 4.5 divided by 9. Let me write this down. I'll write it down here. Gradient is equal to 4.5 divided by 9, and that's equal to half. So m is half. Now we have the formula. A is half and B is 0. So I'm just going to write this down. Okay, I'll do it right here. I is equal to half B squared plus 0. That is our answer. That's the formula connecting current and diameter. I equals to half D squared. Okay, there's no B because it's just 0. So that's how we can turn an equation containing, for example, a square into a straight line. And the trick is to associate, in this case, D squared with X and I with Y. And we can actually also do this for other types of equation. It can be a square or a cube or even a square root. Okay, but be careful that we can only do it if we have two variables, okay, where we can match with the x and y. If there are many of such variables, then it's too complicated. Okay, next I'm going to talk about quadratic equations. I'm going to talk about graphs for quadratic equations. So let me start with one example. Y is equal to x squared plus x minus 2. As I've mentioned before, if there is an x squared in the equation, then when I plot this graph, I will get a curve. The graph would be a curve. It would not be a straight line. But you may ask, can I not do the trick just now and turn this into a straight line? If I say that the x squared here is, say, a capital X. Now we can't, because if you, for example, compare with the y equals to mx plus c formula for straight line, you can say that we let y be capital Y and x squared be capital X. But what about the x? You have an extra x down there, okay, and nothing to associate with on a straight line anymore. So it just doesn't work. In a way, the quadratic equation is a bit too complicated for the straight line equation. So if you want to make a graph, we have to plot the actual thing. We have to plot the curve. Okay, there's no way to turn this into a straight line. So let's make this curve quickly and see what it looks like. Let me calculate some numbers quickly and try and plot the graph. So when x is minus 2, that's 4 plus 2 minus 2. So that's 4. When x is minus 1, 1 plus 1 minus 2, so that's 0. X is 0, I have a minus 2. X is 1, I have 1 plus 1 minus 2, so it's 0 again. When x is 2, I have 4 plus 2 minus 2, so that's 4. Okay, I've made a mistake. Wait. Now, when x is minus 2, I have 4 minus 2 minus 2, so that should be 0. It must be wrong as well. So that's 0. When x is minus 1, I have 1 minus 1 minus 2. So that's minus 2. That's more like it. Okay, I would like another point here. Let me add one more number. Let me add a minus 3. Okay, so when x is minus 3, I'll have 9 minus 3 minus 2, so that's a 4. Yes. Okay, so I have this set of numbers and I'm going to plot a graph with this. Let's do that. Vertical axis, okay, horizontal axis, x and y. So x goes from minus 3 to 2, so let's do minus 1, minus 2, minus 3, 1, 2, okay, and y goes from 4 to minus 2 to 4 again. Right, so 1, 2, 3, 4, minus 1, minus 2. So I've quickly marked out the highest and the lowest values for x and y. Now, so let's make the points now. When y is minus 3, y is 4. So minus 3 and 4, so go up to there. Okay, the point is about there. Then minus 2 and 0. Okay, minus 2 and 0. There, that's the 0. Minus 1 and minus 2. Minus 1 and minus 2 here. And then likewise, the 0 is minus 2 again. Minus 1 is 0. Minus 2 is 4. So there we have the points and we can draw a curve through them. Okay, it takes some practice to make the curve look curved, to make it look like a nice curve and smooth. So you should try this out a few times to make sure you can do it. So this is our curve. It is the curve on the graph that represents this quadratic equation. And because it comes from a quadratic equation, we often call this a quadratic curve, because you can imagine that there can be different types of curve that curves in different ways and in more complicated ways. So this particular type of curve, we can see some obvious features, like it goes down and come up again and is symmetrical. Okay, so this type of curve is called a quadratic curve. Alright, so that's what the graph of a quadratic equation looks like. Okay, now I'm going to start looking at ways to make use of graphs to help us solve equations. Now there are many uses of graphs. You're just looking now at how to use graphs to solve equations. Now what do I mean by that? Now we have this equation here, y is equal to x squared plus x minus 2. This is not an equation that we can solve because there is x and there is y, and x and y can take many different values. So we cannot solve it in the sense that, in the sense of finding a fixed answer for x and y, because they are not fixed. Alright? But let me make a problem. Now suppose I make this equation 0 is equal to x squared plus x minus 2. Now that is an equation that we can at least try and solve. It is an equation that contains just x, and you have seen this kind of equations in algebra. There are things that we can try to do to solve for the x. In this case, there is an x squared, so it's a quadratic equation. So you can try ways like factorizing, alright, or even just try and error. Now, but what I'm going to show now is that you can also use a graph to solve this equation. In fact, we can use this graph. How? Compare this equation with that equation. Okay, this one has just x, there is no y. Now that one has x and y. So if you look at the right hand side of these two equations, they look exactly the same. You have x squared plus x minus 2, and you have x squared plus x minus 2. The difference is that instead of the y, we now have 0. Now the idea here is that we compare this equation and we say that they are really the same except that y has become 0. So what I could do is that I could go to the graph and look at the points on this graph, on this curve, where y is 0. So let's find those points. Now let me just start with that point. There. We know that point, we plotted it using -3 and 4. So at that point, we know that the x is -3 and the y is 4. But that's not the point we want. We want a point when the y, alright, when the y here is 0. But on that point, the y is 4. So let's move to another point. If you pick a point somewhere along there, the y wouldn't be 0 either. It would be somewhere here, maybe about 2. So I should keep coming down until I reach that point. Now that's the point that I want, because at that point, right, at that point that lies on the x-axis, the y value is 0. So I found the point. So on this point, the y value is 0. Okay, the y value is 0. What about the x value? Okay, on this point, the x value is -2. Okay, because 0, -1, -2, -3. So on this point, the x value is -2. And that means that -2 is an answer to this equation. Why is that? Because we know that at this point, when x is -2, y is 0. That's what this point is about, right? So, and I know that this point comes from this equation. Okay? It's just saying that when x is -2 in that equation, y is 0. But that's exactly what we have in this equation. We have this x squared plus x equals to 2 is equal to 0. Okay, and because this right hand side is the same as the right hand side there, so when x here is -2, I would get 0 there, and therefore x equals to -2 is the answer. So we have our answer here. X is equal to -2, and we can get this just by looking at the graph. Now you may have already noticed that there is another point where y is also 0, and that's that point. On that point, y is 0 and the x is 1. So this means that when x is 1 up there, the y is 0. So if you come down to this equation, it also means that when x is 1 here, okay, the y is also 0. So therefore, x equals to 1 is another possible solution. So we know that we can expect two solutions because we have learned quadratic equation in an earlier session, and we have seen that you can have two answers for the quadratic equation. And if I just come back to this graph again, okay, and think about what we have done, what I've done is basically I have looked at the 2 points where the curve cuts the x-axis, that point and that point, and I've looked at the values of x at these 2 points, and it turns out that those values of x gives me the answer to this equation. So that gives us a very useful and simple way to find the answer to a quadratic equation. So if you have this equation and you want to find the answer, one way is to plot the graph and find out where it cuts the x-axis. Now, but be careful, in an exam question, you cannot always do this. If an exam question asks you to solve a quadratic equation, unless it tells you to plot the graph. The reason is that although you can be very careful and plot your graph very accurately on a piece of graph paper, not all quadratic equations, not all equations like that would have the curve going through an exact number on the graph. Like for example, here it goes through exactly -2 and 1, and you can easily see from the graph that it goes through these 2 points. But not all quadratic equations have answers that are whole numbers. Some may have a decimal or even an irrational number. So may have a decimal with many decimal places. And if that happens, okay, from the graph itself, you can only get an approximate answer when the curve cuts the x-axis, and that may not be acceptable if the exam question needs you to solve this accurately. Then you would still have to try and use factorization or some methods that you learn in algebra. Okay, so that's it about using quadratic equation to find, to plot a graph and to solve the equation, an equation like that. Okay, we'll stop here for this session.